Welcome back, Marauders. This video 16.10, we're talking about acid-base behavior and chemical structure. So we want to be able to predict how strong or weak an acid is, or compare to acids, by looking at their structure. Basically, any molecule that has hydrogen in it could be a potential acid because it can potentially lose that hydrogen, and that's what acids do. They donate protons. So if you have a strong bond between hydrogen and the rest of the molecule, then it's a weak acid. And if you have a weak bond between hydrogen and the rest of the molecule, then it's a strong acid. So typically you're going to have something connected to hydrogen. And if this bond is really weak, then the hydrogen can be lost really easily and become hydrogen ions. So that's why if this is weak, if it breaks easily, then you can lose the hydrogen and it's a strong acid. But if this bond is really strong to hydrogen, then you can't lose the hydrogen as easily and it is a weak acid. All right, so let's take a look at some more detailed examples. For the binary acids, that means hydrogen connected to just one other atom. The stronger acids are as you move to the right on the periodic table because of electronegativity. So as we move from left to right across the periodic table, let's look at if you had like sulfur connected to hydrogen and if you had chlorine attached to hydrogen. Well, we know that as you go from left to right across the periodic table, you have an increase in electronegativity. So chlorine is really good at pulling the electrons towards itself, has a really high electronegativity. Well, what does that mean? Well, if it pulls the electrons away from hydrogen, then hydrogen is easily becoming a proton. And so it can easily break this bond when it pulls all the electrons away, then the hydrogen can just float off as a proton. Over here with sulfur, it's pulling the electrons, but not quite as strongly. So this bond is a little bit stronger and it doesn't turn hydrogen into a proton quite as easily. So this makes it a weaker acid, and this a strong acid. The stronger acids also occur as you move down the periodic table, and that's because of size. So if we were to compare hydrogen connected to fluoride or hydrogen connected to chloride, well, we know that hydrofluoric acid is a weak acid. Hydrochloric acid is a strong acid. Why is that? Well, since chlorine is bigger and fluoride is smaller, these two can get really close, and that makes the bond strong. Okay, so since fluoride is very small, these can get close and it can make a strong bond, therefore making it hard to lose the hydrogen. So it's a weak acid. Chlorine is quite a bit bigger than fluorine, and so that makes a little bit more distance between these. So this is a longer bond, therefore a weaker bond. And when it's a weaker bond, then it's easier to lose this hydrogen. And so that means it's a stronger acid. Looking at the strength of oxyacids. So these are ones where you have an oxygen connected to hydrogen. So the first thing we'll look at is if you have a central atom with a high electronegativity, then you have a more polar bond and it makes the acid stronger. It makes it easier to lose that proton. So if we're comparing these two, H, and then the hydrogen is always going to be connected to the oxygen. So even though the formula is not written out like that, in the molecule it'll look like this: hydrogen connected to oxygen, oxygen connected to chlorine, versus this one, hydrogen connected to oxygen connected to iodine. So here we have chlorine, which has a high electronegativity, so it's good at pulling electrons towards itself. Iodine, not as good at pulling electrons towards itself. Well, as this pulls electrons away from the oxygen, that'll in turn pull electrons away from the hydrogen, and then this means it's turning into a proton. When it loses that extra electron, it becomes a proton, and so this can be lost easily. And so this would be a strong acid because the chloride with a high electronegativity pulls electrons away and therefore makes it easy for that proton to break off. Here, you don't have as much of that. So this ends up being a weaker acid because you have a stronger bond. It doesn't pull the electrons away from the hydrogen as much, and therefore a stronger bond doesn't lose those protons as easily. Also, along with the oxyacids, sometimes you have ones with the same central atom, but you have different numbers of oxygens. So for instance, if we look at HClO4, so you have a hydrogen connected to oxygen, connected to chlorine, and then 3 more oxygens. So this one looks like this. And then we'll draw this one for the biggest comparison. So if we have hydrogen, oxygen, chlorine, and no more oxygens over here. Well, all of these oxygens have pretty high electronegativities, and so does the chlorine. So this is pulling electrons, pulling electrons, pulling electrons. Everything is pulling electrons away from this bond, meaning that this bond gets weak and pulls electron away from that hydrogen, meaning that this can become a proton and be lost pretty easily. So all these extra electrons make it a stronger acid because it makes that bond weaker by pulling the electrons away from it. Over here, we don't have those extra electrons out here, or those extra oxygens pulling electrons out here. Therefore, this is a stronger bond and a weaker acid.